Welcome all to my fifth lecture. Let's recap the four different lectures what we have discussed in the previous lectures. Lecture 1, we have discussed the user-defined data types and the primitive data types, the different data types which is available in C. Lecture 2, we took a header file. We tried to understand what is a structure declaration and what does it really means. We have really seen what is the purpose of a header file. Lecture 3, so the Visual Studio Code make file. So we have seen the step-by-step process to install VS Code, to how to write a small program, compiling and debugging also we have discussed. In the lecture 4, we took different practical examples, simple functions, how to write, and finally we have seen how to compile and debug as well. So this is lecture 5, where we'll try to take, we'll see how to write our own header file, and also we'll try to understand some uh, key static inline, static keywords, some practical example as well. So if you see, the lectures are intended for the people who are beginning their careers in the embedded, and also it's an generalized information. It's not like very highly technical information, but what I'm guaranteeing is you will be able to gain some good knowledge in a short span of time. So hope we are in the fifth day of challenge, and you are patiently you can take up the other lectures as well. What is a header file? Like what happens when a structure is declared in a source file? What is a static function means inline, and other key points we will discuss in this lecture. So, so in the previous lecture, we have discussed the block diagram of the microcontroller. So normally, if you see, we have a CPU, flash and RAM, the memory, and then you can have different peripherals. I have tried to show you only three peripherals, but you can see more peripherals in a typical microcontroller. So the motivation behind this lecture series is you should not take anything for granted. You should not by heart yourself that okay, structure means you should always declare in a header file. No, you should try to understand, or you should try to keep asking yourself a question. If you see something, what is the reason behind that? So, like such things you should ask yourself, and then you try to find answer for such questions, right? So normally, if you see a header file, if you see normally the header files where you can see the declarations of the structure and functions, some macros, constants, you can see, and then also we will see some static inline function also we will see in a header file. So let's try to understand. Can we declare the structure in a source file as well? Yes, it's absolutely possible. So if you want to use the structure or the function in the same source file, then you can very well do it in the same source file also. So that is the first point what I want to try to show you. So let's show that with some practical example. So we have this VS Code, and in the previous lecture I tried to show you an integrator, how to implement an integrator for a given signal. So basically, the integrator consists of four different elements, or it needs four different elements. One is sampling time, and the integrator, it is a memory element. It try to store what is the previous signal value, and then the present signal output signal value, and what is the input signal value which is coming to this particular integrator block. And then we have seen this integrator function, which is having an data type argument, which is having integrator, and then a return type of float. So if you see what we have done is we have this main.h file. So in the main.h file, the function declaration, so that is nothing but this, and the structure declaration we have seen. Yes, and then if you try to type just make in the terminal, you can see that. Okay, maybe no make file. So I think I just want to like put my make file over here. And then let's paste my make file, lecture file. Yes, let's paste the make file. So now if I go over here, so main.c is the file what I have. Yeah, then if you just go to terminal and if you just type make, yeah, you can see the main.object file and the output.exe file got generated. Now let's try to understand, like, can I can I declare my function and my structure in the uh, source file itself. So main.c is our source file. So I'll try to, try to declare in the source file itself. So you can see this dot means it's not saved. So I have saved it. Now if I try to, type make, and again, you can see that, yeah, the updated file, updated executable file got generated. So this is what I want to show you, because the function is also used in the uh, same source file, and the structure also, like the structure, input voltage and input current also, you are using in the same source file. That's the that is the reason why you are okay to declare it is in the same source file. Now let's try to understand the next point. If we want to use the structure or functions in a different source file, then you want to declare the structure in a header file and you want to include the header file. Now let's try to understand that. Now maybe let's try to take this particular uh, you know uh, this particular variable I want to use it in a different source file. So let's try to create a new file. So maybe let's call it as signal processing.c file. So I'll just create this new file. I want to create in the same like level. So I have created this, and then what I'll do is, yeah, I'll just try to take this uh, yeah. So integrator input current. So I basically want to use this integrator in a different source file. So let's try to do that. And then maybe I also, I will just have a function here. Let's say that, let's say that it's integrator current, like something like this. I'll try to have a function. Yes, so now I want to implement, or the function definition I want to use here. So I'll try to do that. Maybe let's try to put void. Normally, it's always better to do this. Now, what I want to do is, I want to just have this same, function. Let's try to go to signal processing.c, and then I'll try to paste over here. Okay, now, so like, yeah, in place of this, I should have something like this, and then I want to call this function. Iterator function is also defined in a different source file. So now let's try to understand such this concept. So first, what you want to do is you want to take this function and you put it in the main.h file. Okay, now you have done this, so you can see the integrator function. Uh, will detect once you include the main.h file. So I have included this main.h file. Now you can see the compiler will detect this particular function. Then what you want to do is you want to it should try to see the definition of this integrator. So to do that, so what I'll do is I'll just go over this particular structure. I will come to the main.h, all right, and then I will try to paste over here. So the you have this integrator now definition also. So I have saved it, and also uh, what I try to do is the data type also. It is always better to have it in in a header file, and so that all source files will see this data type, right? So now Now let's try to see the program first. So it's looking good. So you have this integrator current. So but yeah, you want to have this as I discussed in my previous lecture. So if you call this function, and if there is no the definition, if it is not there before the call, then it will give an error. So for that you need the definition of the file. So we can just define this file also in the main.h file. So I will do that as well. Yes, so I think we are good to go. Let's see this. So I have my integrator current, and the integrator the integrator current definition is in this file, right? So I'm coming over uh, coming to this integrator current, and then the integrator function, rather than it should be input current. Yes. So now let's integrator current is there, and in the main.h also we should not see any error. Okay, so I think we are good to go. Again, I'll try to explain. So I have this structure integrator. So in one of the source file, I want to uh, use a variable called input voltage. In a different variable, in a different file, let's assume that I want to create an instance of this structure. So you want to have the definition. So if it is in the source file, we cannot, we can very well do hash include main.c. Then the problem is the uh, for C, the main thing what you want to understand is, for an integer a or for any data type, the definition should be always only once, right? So you cannot, that is the reason why you cannot include the main.c file, right? So hope you are able to follow me. Now let's try to try to do the make. So before doing a make, what you want to see is in the make file you have another file. So this is the beauty of having a make file. You just want to uh, add the new source file, and also we are trying to say that please compile all the source files together. So that's what it means. So now let's try to type make. Yeah, you can see the two different the signal processing.o file as well as main.o file is got generated. So I hope you have seen some practical example. Next, what we want to do is when we will use extern for structures, right? So this is also something you want to understand. When we use the same structure variable in a different source file, then you need structure. I'll try to show you that also with an example. So let's assume that rather than uh, like this input voltage, rather than using over here, let's assume that I want to use it over here as well, right? So in this case, what you want to do is, it's very simple. Go to main.c, and you just want to convey that this particular structure variable is an extern. Let's try to show you. So this is something extern, right? Yeah. So now what we are trying to say, this is an external variable. So somewhere the structure instance is created. This is one of the important thing you want to really understand when you take a C2000 microcontroller datasheet header file. You will see external volatile, something like that. You will see at the end of the header file. So this is what you want to understand. So we have declared the structure, and also we have conveyed that the instance is created. Now this instance, you want to define that instance, and we are saying that the definition is somewhere in some other source file. That's what the meaning is. Now you can see the compiler have detected the input voltage structure as well. So this is also another example what I want to show you. So you can see the the output.exe file got generated. Now let's try to also understand a concept. Function declaration, if you declare extern or not, function declaration is always considered as an extern. This is also one of the concept what you want to really what you want to understand. So what I'm trying to say is, like this in generator current is there, right? So this is some function what we have uh, uh, declared. This. So if you have this extern, or if you're not having an extern, so it doesn't matter. That's what it is. So nothing to be done, because yeah, it's not able to see any changes. So if do the function declaration, just the data type and the argument, or if you put extern, so the compiler will not see any difference in a function declaration. This is also one of the point what you want to understand. Now let's try to understand what is a static and inline function usage. So normally when you work for some bigger projects, you can see some static inline functions are getting used in header files. So first of all, static keyword in a function keeps that function accessible only in that particular source file. So if you have a function which is defined as a static, so then it is accessible only in that particular source file. So what does it means? Let's try to understand with an example. I'll try to create a small function, a static function called as add. And let's try to define this function in the header file. Sorry, in the same source file. Return a plus b. And then when you try to uh, call this function, everything looks fine. So this is the normal procedure of static function usage. So you have the declaration and then have the function call, and in the same source file, you try to have the function definition as well. And if you can see that, yeah, so this is a normal procedure. So now let's also try to understand what happens when we try to have the function definition, a static function definition in a header file, right? So let's just try to take the definition and then try to put it in a header file. So once you have the function definition itself in a header file, then there is no need of a function declaration, because the before the function call, the its definition is seen by the compiler, right? So when you do so, it says, it gives a warning saying that add defined but not used. Here the problem is another source file is also including this main.h file as the keyword static means. So in this .c file also the .h file is included, and it sees the static keyword and says the definition is available, but like we are not using it. So that's what it means. So you can also, the static function should be that source file, or can be included in the like a header file. You can define it and then include it, but the problem is the compiler gives a warning. Now let's try to understand the next point. If the static function is defined in a header file and called from multiple source files, this increases the code size. Now let's try to call the function, maybe the same function. Let's try to call in a different source file, right? So this also works perfectly, and the warning also will goes off as expected, because now the function definition is also seen, in both source files. But the problem here is we also want to understand what is the problem or disadvantage. This increases code size because both the files gets local copy and the same function is getting used in like the same function is getting used in two different source files. So this increases the code size. So if you really want to avoid the function calls, so normally when you call a function, it includes some push and pop operations. So this will consume some time. So if you really want to avoid this, so normally we will use this static inline function, right? So so what does it do? So just you want to go to the static and then just type this static inline, then yeah, everything works perfectly. But what we want to understand is like, again, it creates the local copy in each of the source files, but there is nothing called, you cannot see this, like this term. Once you try to, do some detailed analysis, this function name will not be there. Directly, it will replace wherever we are calling this function, it will get just replaced by this return a plus b by the usage of inline. So this is the advantage of having a static inline function. So normally, let's assume that you want to set some pin, GPU set pin. You want to do some debugging and you want to try to use this in a 10 microsecond ISR or in 5 microsecond or in a very short span ISRs. Then normally this usage is highly recommended because it highly optimizes the runtime in the control ISRs. So now let's try to jump to the next topic. So in the previous lecture, I tried to explain, the memory definition for a GPU register. I tried to show you for a GPU register for the TMS 32015X. I tried to show you some practical insights. How does the memory definitions happens here? So now let's try to create our own header file. If you want to create our own header file, how should we do this, right? So it's very simple. If you just go to file, new file, let's try to create our own header file. I just tried to create this gpo.h file. Maybe I'll try to give some name as well. F280015X gpu.h file, right? Then what we want to do is we want to open the data sheet of the controller. So I have opened the data sheet. So you can see the different registers. To start with, the first register is GPA CTRL. So basically you can see the GPA CTRL, it's a 32-bit 32-bit, out of which there are 4 different elements, right? But these 4 different elements is coming under a single name called as GPA CTRL. So what should we do? We should define a structure. All right. So I will define this structure, and I'll try to give the name, the same name GPA CTRL, right? And then I'll try to have the these sub elements. So what all are the sub elements? So the sub element is maybe let's try to give the sub element names. So unsigned 16. First one is the qualification period 3, right? So which is basically 8 bits. So you should implicitly mention that it is 8 bit, right? Then what we want to do is the other one is qualification 2. So we'll try to do that. Then it's qualification 1. And then what we have is that's right. So just a structure you have declared, which consists of these four different elements, right? Now, if you want to access the whole 32-bit, then what you want to do is you want to use the union keyword, right? So the union keyword you want to use. Now, what should we do is, let's say that uh, we are giving a different name. Let's call it as the complete register. So that's the reason why I'm calling it as the complete rec. So now I want to use this, either like take this structure. I want to uh, use this structure inside this union. So now what I'll do is I will have this bits. This is one thing, and another what I'll do is I'll just have a 32-bit you know uh, 32-bit element to access the whole structure. So if I want to use individually, then I will try to use the bit. If I want to write the whole 32-bit, then I'll try to use this, the whole, right? So now let's try to compile this. So now the problem is here it's not seeing uh, you know uh, the function, the usage of unsigned 16. So to do this now, like if you just try to include the the whatever the header file which we made, the TMS 320 F280015X GPIO.h. So now when you try to do this, I think, yeah, unsigned 16 is defined. Now maybe let's try to define the 32-bit as well. So it's unsigned in, and we are saying that unsigned long, it's 32-bit, right? So yeah, now the compiler is able to see the structure, the structure declaration for the two, or the one 32-bit 32-bit register, whatever we seen in the technical reference manual, right? Now, next, if you want to do the next structure, what is coming is GPAQ cell 1. So we'll just try to do that again. We'll just take this, the GP, the next one is GP. So let's try to put the same name, and then let's try to give uh, the sub elements. So this GPAQ cell 1 consists of various sub elements which consist from GPU 15 to GPU 0. So I'll try to just paste this uh, just paste this usage. So I have done this, right? Now, so I have done this part, right? Now again, if you want to access the whole thing, then what you want to do is this, union. Again, you want to use the union. So union, and then use this uh, the same keyword itself. Maybe let's put right, and then then if you want to have the uh, have the complete structure, bitwise, then yeah, I just created GPAQ cell 1 and created an instance of bit, and then I try to create the whole the if I want to write the whole element, then I'll try to use this whole keyword, right? So this is what the next is. So in the same way, you can go ahead with all the structures which is given in the like given in the reference manual. So I'll try to show you now the device support, Linux, and yeah, the headers, right, and include, and then let's try to see this gpio.h file. Yeah, you can see it's like it's the same. There is nothing much difference. You can see it starts with the same name. You know, like okay, they have used GPA CTRL bits, but whereas I try to use just the GPA CTRL. It doesn't really matter the name how you use even bit. You can give some other name as well. It's absolutely no issues. So then you can see the next structure goes on, and you can see the each and every structure will come into the picture. And then finally, what you can see is this GP GPU CTR Rex is the main structure, and that structure consists of these many, sub elements, right? So, so that is what you can see here. You can see in the structure, you can see this particular element. So GPS CTL register, which consists of various other sub structures. So this is what it means, a header file provided by the OEM, right? And then you can see at the end of the file, you can see this keyword. So this structure, we have created an instance, and we are saying that it's an extern volatile struct. So it's an extern. So it means the structure instance, actual instance, or the structure definition is done in some other source file. That's what it means. And once you include this header file in any of the source file, you can just you can directly use this structure in any of your header files, provided the definition should be available somewhere in some source file, and the link and the compiler should be able to find the uh, the structure definition in any of the source file, right? So this is what it means. So so I try to show you what is the understanding of a header file. Why do we have an external volatile struct? That also I tried to explain. This means the structure definition or instance creation or variable creation will be in some other source file. And then we have discussed in the previous lecture. So basically, this is just a high-level C language interface document. I'll call this header file as an interface document, which helps the peripheral registers in a very defined address space. So we'll try to explore or try to understand more in the coming lecture. And in the same way, if you try to see the different different header files, you can really try to understand, what does the different, the header file means. For example, let's try to take the ADC part. So let's quickly jump to ADC. So anywhere you can see this ADC. Once you go, you can see this ADC register. So by seeing this itself, you can understand, okay, it consists of two different ADC modules, ADC A and C. So it's basically two different physical hardware sitting, and then you want to use this ADC modules to convert your analog to digital value. So what we'll do is the structure definition is saying, and then you try to create just an instance for two different, ADC modules. So ADC result rect is common, structure is common. You are creating one instance with a different name, another instance with different name, and both these have a defined memory in the memory space. That's what it means. Hope this video was an insightful and meaningful one. Thanks for watching, and see you all in the next video.